Here's a situation that brings up or begins this process of talking about order of operations. It turns out that some operations take precedence over others, and we need to perform operations in a particular order in order to get the correct result. Now here we have 3 squared minus 4 divided by 6, and the tendency might be to try to cancel the 3 with the 6 or the 4 with the 6 before we continue with the problem. And we're not supposed to do that. We're not supposed to perform or take advantage of those cancellation opportunities in this part of the problem. As a matter of fact, anytime there are 2 items in the numerator and we have a single item in the denominator, we can't really cancel that single item in the denominator with both parts of the numerator. And there are ways to deal with it, but we'll have to look at those in the future. Our order of operations tells us to square first. We take care of exponents before we take care of other things in a problem. So 3 squared would be 9, and we'll write this then as 9 minus 4 over 6. And now this 9 minus 4 in the numerator will be handled as 5, and then bring down the 6. This becomes 5/6. Again, we have this, it looks like a cancellation opportunity with either the 9 or the 4 or with both, you see, but we can't do that. We have to collect everything in the numerator, perform all the operations in the numerator before we look for those cancellation opportunities. So 5/6 is the answer here. Here's a more clear-cut example of the order of operations situation and the dilemma that we sometimes find ourselves in. Here I've written 2 plus 3 times 4 twice. And if you just look at this at first glance, you might say, well, one person might say, well, let's perform operations from left to right. This is 2 plus 3, that's 5, and then 5 times 4 gives 20. And somebody else will say, no, let's perform the multiplication first and give us 2 plus 3 times 4, 12. 2 plus 12, 14. 2 very different answers here, and yet it's exactly the same problem. And which one is right? Well, it turns out that this way to do the problem is correct. And we simply have to agree on which operations are going to be performed first. And it's not always just a matter of performing operations from left to right. It turns out that multiplication and division are performed before addition and subtraction, if there is a choice, as there is in this case. Now, you take the choice out of the whole situation by using parenthesis. Now, we know that parenthesis means to multiply, but it also means to do this first. It means do me first in a problem. And it means also to multiply, but doing it first means to work within that parenthesis before going on with the remainder of the problem. So if someone were intending for the 2 to be added with the 3 before multiplying times the 4, then the way to indicate that is with parenthesis like this. So this says, do this first, you look in the parenthesis, perform the operation, and we've done it here, and then multiply times 4, and bang, we have our answer. So now, written like this, that's the correct answer. Here's another problem involving parenthesis, and in fact, this problem involves another symbol of inclusion called brackets. There are actually 3 kinds of symbols of inclusion. Parenthesis is one of them, brackets is another, and braces is a third. The braces were used for set notation before, but they can be used in this situation also to contain certain items within the problem. Now, in situations like this, where we have symbols of inclusion inside of one another, when they're nested like this, you want to work from the innermost symbol of inclusion. There's a strong temptation in this problem to simply add the 3 and the 2, and we need to resist that temptation. It seems quite intuitive to do that. But the symbols of inclusion, particularly the innermost symbol, is just drawing us to that part of the problem, and it's saying, do this first. Do this first. So we're kind of magnetized to that part of the problem, and we ignore everything else. In fact, we bring everything else down. So we just write 3 plus 2, bracket, negative 3, and all of our attention is right in here. So we look in here and perform this operation. 5 minus 3 is 2. Now, once we have done that first, once we have done all of what is inside the innermost symbol of inclusion. We work our way out of it by performing the indicated operation. And the indicated operation is multiplication. We're multiplying the 2 times the negative 3. So we'll bring down the 3 plus 2, and then negative 3 times 2, negative 6. And now, notice that the parenthesis disappears once we perform the operation that is indicated here. So once we perform that operation, it's gone, and now we're in this bracket, and within the bracket is negative 6. There are no other operations within the bracket, so we work our way out of it by performing the indicated operation of multiplication. 2 times negative 6 is negative 12, so we write 3 minus 12. Now, it would be okay here to write 3 plus negative 12, but it means the same thing to write 3 minus 12, as we saw earlier. Well, the 3 minus 12, we have different signs, so we end up subtracting, take 3 from 12 to give 9, and attach the sign of the larger of these two, and that sign is negative. So negative 9 is the answer. Here's an outline of our order of operations agreement. We agree that we're going to work within grouping symbols first. And that's kind of like the parenthesis, meaning do this first, and then we'll take care of any exponents that are in the problem, and then we'll perform multiplications and divisions from left to right, and then addition and subtraction from left to right. Here's an example of a problem involving grouping as well as exponents. So we have the grouping. We're thinking of this as a grouping symbol. We also have an exponent applied here, and we have a multiplication. Now, to decide what to do first, the parenthesis says do this first. Work within the parenthesis first. So we're thinking 4 times 5 minus 2 is 3, and we bring down that exponent. Now, notice that in this process, and for many of the problems that I'm working, I'm performing fundamentally one operation at a time, and I'm writing down the next step. There's a tendency to want to skip steps here. There's a lot of temptation to say, well, gee, I can do this, and then after that I'm going to do this, and then after that I'm going to do this, so I'll write all that down in one step. And it just doesn't work that way. I mean, it doesn't work out well in the long run that way, because problems get increasingly complicated. And as we grow in complication, the way to take care of the complication is through organizational skills, and that means to show all of the work, to show the various steps. In algebra, really, it's a matter of always writing. In algebra, you should always be writing. If you're not writing, if you're trying to ponder what you're going to write next, then chances are you're trying to skip steps, you see. So that's kind of a pretty good indicator. The next thing that you need to write down should be pretty much obvious. You're looking at the one thing to do, and you're going to do that thing, write it down, and then do the next thing, write it down, and it's a very safe way to proceed. And it turns out that it's just as fast as the other way anyway, you see, because you spend so much time pondering the skipping of steps that it wears you out. It exhausts you mentally, and it takes up a lot of time. Well, at any rate, here, 5 minus 2 is 3, and now we take care of the squaring before we multiply times 4. Now, if we were to multiply 4 times 3 first and get 12, and then square the 12, the 4 would be a factor within the 12, and the 4 would be part of the base, you see, of that exponent, and it's not intended here. The 3 is the base of the exponent, and only 3 then should be squared. So this should be written as 4 times 9, or 36. In this one, we have an outside minus sign, an inside minus sign, and we have this exponent. Now the parenthesis says do this first. So as a grouping symbol, we're looking inside to see if we can simplify. No, negative 5 is already in simple form. So we'll raise to the 3rd power. Now the complication here is this outside minus sign. There's a kind of a tendency to say, well, let's deal with the 2 minus signs. 2 minus signs mean plus. And it may turn out that the answer is positive, but it isn't because we're taking care of those 2 minus signs. It's for other reasons here. But whenever there's confusion about what to do next, or if we're not sure about what to do, then go to your fundamental idea of what you have in front of you. Here, for example, we have an exponent of 3, and just basically, conceptually, that means we have 3 factors of that base. So this is minus and then 3 factors of negative 5. And you really can't go wrong when you write down stuff like this. You write down your concept of what the meaning of what you have here is. Oh, okay, now I'll just multiply this out. This is really negative understood 1 times negative 5 times negative 5 times negative 5. Now, because we have 4 factors, all of which are negative, an even number of negative factors, that's why the product here is going to be positive. And then it's 1 times 5 times 5 times 5, that's 125. Here we have fractions involved, and notice that there is a temptation here to take advantage of what looks like a cancellation opportunity here and here, and we resist that temptation because the parenthesis says do me first. Well, this is simple, and that's in simple form as well, so there are no operations within the parenthesis. But the next part of our order of operations agreement says to take care of the exponent. So we'll take care of this exponent, and it's an exponent on this base. And the easy way to take care of it probably is to think of this as 3 squared over 4 squared. You see, you apply that exponent to the numerator and denominator separately and think of those, the calculations as separate events. So 3 squared, 9, and then 4 squared, 16. And then bring down everything else in the problem. Now, let's see. We have cancellation opportunities at this point. We're just multiplying the 2 fractions. So 2 into 2 goes 1, 2 into 16, 8. 3 into 3, 1, 3 into 9, 3. And now multiplying straight across, 1 times 3, 3, 1 times 8, 8. So 3/8 plus 2. 3/8 plus 2. Oh, that's just 2 and 3/8. Now, another way to deal with this or to find the same value is to think, well, we're adding 2 quantities here. We think of 2 as being 2 over 1. We need a common denominator. The common denominator is 8. We would say, gee, this is 16/8. 16/8 plus 3/8 is 19/8. And then write this as 19/8. And then from there, change it into 2 and 3/8. Well, it's easier to deal with it directly here. We could, incidentally, find the 19/8 by changing the mixed number to an improper fraction. 8 times 2, 16, plus 3, 19/8. So any way you cook it up, it still grits. Here we have nested symbols of inclusion again, and we work within the innermost symbol. And that's this symbol. So we have 8 plus 12, 20. And we would write 360 minus. Now, I can write this in parenthesis or not. If I write it in parenthesis, it's fine. I would be writing this. But do understand that this, to take care of the parenthesis, it means to multiply, and we're multiplying by negative understood 1. Negative 1 times 20 is negative 20. So if I left off the parenthesis at this point, it would have been the same thing as if I put it in. Now, you'll become adept at knowing when to put the parenthesis and when not to. And actually, it's probably a good idea if there's ever confusion, if you're not sure, put it in. And then kind of deal with it, and then by experience, you'll find out when you can omit it. But here we could have just avoided writing it in. 8 plus 12 is 20, so we have minus 20, you see, and just like this. And now collecting in here, we have 360 minus 20. Oh, that's 340, so I could write 340 with or without the bracket because there's nothing being multiplied outside here except perhaps we could think of an understood 1. So 340 then divided by 10, and 340 divided by 10 is 34. So 34 is our answer.